Hey guys, good morning. So last time we did the glycolysis cycle, right? Today I'll be discussing the fructose and the another, if time permits, the galactose one also. So make sure you squeeze in, right? I'm going to share my screen now, right? This is my notebook and the share, and then it sounds perfect, right? So let's begin rather without wasting time. This was the last time notes. Okay. So first is the galactose, or you can write lactose or galactose metabolism is the one. I'm writing the bigger font. You are going to write into the smaller, divide the page into like imaginary line, the two halves. Okay. So in the milk, we have the lactose sugar. Lactose is a disaccharide, Okay, you should be knowing the structures also. You should be able to recognize the structure actually, but I'm not doing it here. I'll release a different video and I'll take all the structures and how to recognize which one is a reducing sugar, which one is not a reducing sugar, and also the various DL alpha beta isoforms as well. Okay, so lactose in our body is broken down into glu and the gal, right? Glucose and the galactose, and the enzyme here involved is lactase. Lactase is the enzyme that is involved here. Now, this galactose via your blood, right, comes inside the cells, inside your organs, right? Which organs we are talking about? Liver, brain. Why I'm mentioning brain? Because brain needs food, that is glucose and galactose and the glucose. You can write down a note here also, right? Galactose and glucose, they are epimers. They are epimers. And for those who are more curious, you may draw the structures here and write it down what kind of epimers they are, because that is a must know thing about the glucose and the galactose. Well, coming back to our pathway, okay, you have the galactose inside the cell and it should not go out. So you need to trap it in, right? We don't want our girlfriend to go with another boy. So we are going to trap the baby, this cute little girl in, that is the galactose, right? The galactose is converted into galactose 1-phosphate and the enzyme is a kinase enzyme. But since we are talking about the galactose, so enzyme name is galactokinase, not the glucokinase, not the hexokinase, right? Hexokinase also is the same. We can call it an hexokinase enzyme, but not the glucokinase for sure. Okay. So galactose 1-phosphate is there. Now this galactose 1-phosphate is converted into glucose 1-phosphate, and the enzyme is very, very special enzyme with the name of the substrate galactose 1-phosphate. Okay, galactose 1-phosphate hai, right? What kind of enzyme it is? This is an transferase enzyme. A transfer is going on. Kiska transfer? With the help of uridyl. Uridyl is what? UDP. UDP, right? Now we have this beautiful girl along with us. Galactose 1-phosphate is the one, right? And we have trapped it because we don't want it to go to another boy, right? And now we want to get married. So the UDP is a white chariot on which your glucose come in, and then there is an exchange. UDP abducts the, किसको abduct कर लेता है, किसको kidnap कर लेता है, galactose को, और बदले में what it is gonna leave? It is gonna leave the glucose here. So that is how you convert galactose into glucose in the galactose pathway, right? But this gets reconverted into this again by the enzyme epimerase. Right? You can call it specifically UDP gal epimerase, but the general name epimerase because they are epimers of each other. So this is how we digest the galactose in the body. We have what? We have glucose 1-phosphate here. We have what? Glucose. Okay, now something went wrong. Never mind. Touch screens, touch screens, touch screens. Okay, so glucose 1-phosphate. Where do you have seen the glucose 1-phosphate? In the glycogen synthesis. If you have not seen it, then you will see it in the glycogen synthesis. Otherwise, this glucose 1-phosphate can be converted into glucose 6-phosphate. Where do you see glucose 6-phosphate? In the glycolysis, right? And also in the gluconeogenesis last step, right? So where it is converted into glucose, right? So these are the three fates, either to go towards the glycogen lysis or maybe the glucose synthesis. These are the three fates of the galactose. Now, what are the kind of enzymes we have seen? We have seen lactase. So if we have to write down the clinical correlate, how we are going to write it down, right? So first enzyme deficiency is lactase deficiency. Lactase deficiency, right? And what we have seen in the question, baby like had the milk, right? And start throwing up, right? Lactose intolerance. Lactose intolerant baby, we call it. Right? And what will be the basic things that clinical symptoms? Diarrhea, right? Diarrhea, bloating, cramps. These will be seen, right? Now, the another enzyme is galactokinase enzyme. So deficiency of this enzyme, we will be seeing cataract. Why that cataract will be seen? That is question. That is a very, very important question. You should be knowing how we are getting the cataract. Okay. So what you have here is the galactose, right? This galactose, if this enzyme is not working, this galactose will be keep on accumulating in the blood, and it reaches to where? It is reaching to the lenses, right? It is reaches to the lens where it is converted into galactitol. Why? Because there is an enzyme known as what? Aldol reductase. Aldol reductase is an enzyme that is present in the lens, which is going to convert galactose into galactitol, right? And this compound is galactitol is osmotically active. This is osmotically active, right? And if you have too much of this old galactitol in the lensophile, it is gonna suck in the water inside, and which is gonna lead to swelling, hence the cataract. And what kind of a cataract we are talking about here? Another important thing you should be knowing, oil drop cataract. Oil drop cataract. Let me check whether the recording is going on or not. Right, it is going on. Okay, so oil drop cataract you will see. There is another cataract that you will see, that is the snowflake cataract, right? That is usually because of glucose getting converted into sorbitol in the eyes, though fructose also gets converted into sorbitol, right? And that leads to the snowflake cataract, not the oil drop cataract. Okay, so this is one. And now the last enzyme is this enzyme, another very, very important enzyme, and you definitely see a question, a short note on this enzyme deficiency, right? And what will be the clinical features? Definitely the cataract. What else? Vomiting. Vomiting. What else? Diarrhea. Diarrhea after lactose ingestion. Diarrhea after lactose ingestion, right? What else we will see? Lethargy. Liver damage. Liver damage you will see. Mental retardation. Mental retardation. What else? Hyperbilirubinemia. Hyper. Just give me a sec. Hyperbilirubinemia. All these things will be seen in the right GALT or galactose 1-phosphate uridyl transphate, or sometimes we call it as a glut. Just come up with a cute name to it. Okay, so this is our galactose or lactose intolerance thing, right? Since there is a space here, right, I just want to give you a few extra things also. You can write it down wherever you have space. I guess I have space here. Find a piece space in the sheet where you can squeeze in into few things, right? The lactose intolerance, how do we do the test, right? Test would be what? Test is hydrogen breath test. Hydrogen breath test is being done. Hydrogen breath test is being done for the oral lactose load. Right? Why it is being done? Because what it happens is this lactose, when it is not getting digested, it is getting bacterial fermentation is going on. Bacterial fermentation is going on. Right? And that leads to the synthesis of the methane, hydrogen, and small organic acid. Small organic acid, right? So that is why, that is how it can be tested by the hydrogen breath test. Right? And what will be the remedy for this? Lactose-free diet, lactose-free formula, lactose-free diet, right? But definitely there is this, you can say exception. There is this exception. They can take yogurt. Most of the lactose intolerant people, they can take the yogurt. Okay, they are capable to it. If the question paper would be very, very difficult, you should be knowing it. Okay, so with this, I'll finish at least this wala part. Okay, and then in the next, we will be talking about the next metabolism, that is the fructose, or you can say the sucrose.